Okay, so let's unpack something truly incredible today. We're going to start with a scenario. Just imagine this for a second.
Hmm.
You're watching someone, and they accidentally drop I don't know, a heavy mug right on their toe. You see them wince, and right then you feel a sharp, throbbing pain in your toe.
And we're not talking about just, feeling bad for them or that sympathetic wince everyone does.
No, not at all.
We mean the actual physical feeling, the heat, the pressure, a real localized pain that your own nervous system is registering just from seeing it happen to someone else.
It sounds like a comic book superpower.
Or
Or maybe a terrible curse, but this is a real thing. It's a documented, though extremely rare, neurological reality called mirror-touch synesthesia, or MTS.
right, and it only affects this tiny, tiny fraction of the population.
So for this deep dive, we want to go beyond just the wow factor.
Exactly. Our mission here is to really get at the core mechanism. We want to understand, of course, what it's like for these people, but more importantly, what is so fundamentally different about the wiring in their brains.
We're basically looking at a brain that's cranked the dial on empathy all the way up to a physical extreme.
To a full physical simulation, yeah.
So let's start with that lived experience because, when people hear synesthesia, they usually think of hearing colors or tasting sounds. Mirror touch it's different.
It's completely different. It's all about the somatosensory system, the part of you responsible for touch, for pain, for physical sensation.
Okay, so what are some of the specific, and I imagine often pretty alarming, sensations these people report?
Well, the key thing to understand is that the feelings aren't vague. They're incredibly specific, and they map directly onto what the person is seeing.
So give us an example. From the sources we looked at, how detailed does it get?
Okay, so if they see someone get a cut, they don't just feel a general ache. They report feeling the sharp sting, the specific pressure of the wound on the exact same part of their body.
Wow.
So if they're watching a cooking show and the chef nicks their finger, they feel that distinct slice. It's a hypersimulation.
And it goes beyond just injuries, right? It's about all touch.
All touch, exactly. If they see a stranger get a friendly pat on the shoulder, they feel that pressure on their own shoulder. If they see someone leaning on a cold window, they feel the chill.
Which is why it's called mirror-touch synesthesia, not just mirror pain.
Right, although the painful stuff is usually what's most disruptive, for obvious reasons.
That brings up a question about temperature then. If they see someone pulling, like, a hot tray out of the oven, do they feel a burn?
They register the heat, yeah. It's often described as this deep warmth or really localized hot sensation. Now, it's important to be clear, their skin isn't actually being damaged.
Of course.
It's purely a perceptual experience. But their brain is treating that signal as if it's 100% real.
That just drives home how immersive this simulation is. But this is where it gets, frankly, a little disturbing. The sources mention it's not just about skin contact. It can be internal feelings, too.
This is a critical point. We have documented reports of people feeling a visceral sensation of shortness of breath, like a mild suffocation, just from watching someone else struggle to breathe.
In a movie, maybe?
In a movie, or even just seeing a piece of clothing wrapped too tightly around someone's neck. It triggers that feeling.
So it's not just mirroring what's on the surface.
Mm.
The system is modeling these deep internal physiological states.
It is. It shows the brain isn't just reacting to what it sees. It's completing the whole sensory loop. It sees the sign of distress, the gasping, the struggle, and it just runs the full internal program for it.
Which would generate the feeling of being choked.
The closest possible physical analog, yeah. And that level of involuntary simulation is what makes this so physically and, psychologically demanding.
Okay, so we have to get to the why. Why are some brains operating with this wide open data connection? It has to be something in our brain's core hardware for understanding other people.
It is. We're looking at the brain's simulation system, which is mostly run by what's called the frontoparietal network. For people with MTS, this system isn't just it's in overdrive. It's working way, way stronger than it needs to for just normal social understanding.
And the stars of this show have to be the mirror neurons. Most people have probably heard of them, but they're the real key here.
Absolutely. Mirror neurons are fascinating. They're these cells that fire both when you do something like picking up a cup and when you see someone else do that exact same thing.
Their whole purpose is to help us understand and predict what other people are doing.
Exactly. It's the basis for social learning, for empathy. It's how we can instantly think, I know what that feels like.
But everyone has these. So what's the crucial difference? What separates the average person from someone with mirror-touch synesthesia?
It's really a two-part issue. It's about the signal's strength and a failure to hit the brakes,
Like
basically.
the brakes.
Yeah. So in an average brain, the mirror neuron system fires up, but that simulation signal is mostly kept contained in certain areas, like the secondary somatosensory cortex, or S2.
And S2 is where the brain processes touch, but not where we consciously feel it happening to us, right?
Precisely. The huge difference with MTS is that the signal doesn't stay contained. The activation is so strong, stronger than necessary is the term the sources use, that the signal spills over. It floods the primary somatosensory cortex, S1.
And S1 is the part of the brain that maps out your own conscious physical sensations of touch and pain.
Yes. So the brain is getting two inputs at once, the visual one from your eyes and this massive simulated one that's hitting the exact same spot that tells you, this is happening to me right now.
It sounds like a filter just isn't working.
That is a perfect analogy. Normal brains have these inhibitory mechanisms that act like a gate. They sort of dampen the signal so you can understand the pain without physically feeling it. In the MTS brain, that gate is stuck open. The sensory regions and the simulation regions have this increased communication.
So instead of a quiet hum of understanding, it's a deafening roar that the brain registers as a real physical event. One source described it as their brain being wide open.
It's a really good way to visualize it. The neurological wall between self and other is just much more permeable. But it's a difference in brain architecture, not a pathology.
That is a crucial clarification. So is MTS classified as a disorder, an illness, or something else?
It is firmly categorized as a rare neurological pattern, or a form of synesthesia. It is not considered a mental disease or illness. It's just a different way the sensory pathways are wired.
This brings us to a huge question then. Is this a blessing or a curse? Because on one hand, it sounds incredibly painful, but on the other, that's a level of human connection most of us can't even imagine.
It's the ultimate double-edged sword. Let's look at the blessing side first. Individuals with MTS have this extraordinarily high capacity for empathy.
I mean, they don't have to guess how someone else feels.
They know. They know it through a physical simulation. This can make them incredibly good at reading people, at sensing distress or comfort levels, because they are physically registering it.
You can see how that would be useful in certain professions, maybe a therapist or physical therapist.
Some sources suggest exactly that. But that sensitivity comes at a tremendous cost. The curse side is, it's overwhelming.
Imagine just walking through life, absorbing every little bump and scrape you see. On the news, in movies, just on the street.
It's described as being intensely physically and psychologically exhausting. Their system is constantly overloaded with sensations that aren't even their own. They spend a huge amount of energy just trying to filter it all out.
I imagine they'd have to avoid crowds or certain types of media.
But that's a very common coping mechanism, yeah. Avoiding eye contact, looking away when they see something that might cause discomfort. A busy mall could be a sensory minefield.
And when that cognitive load just gets to be too much,
Yeah.
the sources mention some extreme physical reactions, people actually passing out.
Yes. That's the ultimate system overload. There are documented cases where people may faint when they see someone else in severe pain. And it's not an emotional fainting spell, it's a neurological shutdown.
A system reboot.
Basically, yeah. The extra load on the brain to process that massive simulated pain signal is just too much to handle.
Wow. That really brings the intensity of this into focus. So it makes you wonder, do the rest of us, do our listeners ever feel anything even remotely like this?
That's a great question. And we do. We all experience a very low-grade, benign version of this. The mechanism isn't alien to us. The difference is just the volume.
So what's the common ground? What's the feeling everyone has that uses these same pathways?
The sources have a perfect comparison. Shivers and goosebumps. Yeah. Everyone has felt that weird, sympathetic chill run down their spine when they see a nasty accident, or even something as silly as nails on a chalkboard.
Oh, yeah. You wince and you almost feel it in your own hand when you watch someone slam their finger in a car door.
Yeah.
That's the mirror neuron system.
That's it, exactly. That little involuntary shiver is proof your mirror neurons are firing and your simulation system is online. It's just a very mild, completely filtered response.
So the crucial distinction, what defines MTS, is that lack of a filter. For most people, the signal gets dampened before it hits that me part of the brain. But for someone with MTS, it just barrels right through.
And lands in S1, where it becomes indistinguishable from a real sensation. The average brain uses its filters to protect the cell from being overloaded. The MTS brain, because of its unique structure, just can't do that.
What an incredible deep dive into the brain. We started with this idea of feeling someone else's pain and traced it all the way to this unfiltered neural connection. It really shows that empathy isn't some abstract concept.
No, it's a measurable physical process.
And it shows how thin that line really is between what we perceive as happening to ourselves and what we observe happening to someone else.
And that, I think, is the profound takeaway here. These rare cases show us how fragile the idea of self is in the brain's circuitry. It reveals that the system we use to understand each other is rooted in this involuntary physical simulation. And it leaves you with this thought that the true complexity of human connection, of how the brain manages that boundary between me and you, remains more mysterious and powerful than any algorithm in the world.